All right, we're back. We've been moving into a new unit talking about ArrayList. In our last video, we covered these methods. I'm not exactly reviewing these things, but I am saying that you need to know these going forward, especially for what we're talking about today, because I'm going to be using these, right? First of all, add is overloaded, right? We have this version that'll just tack it on to the end. It'll append it to the very end of our array list. Don't worry about this boolean. We have this add, which takes in an integer index and the object that you want to add. It's going to insert it at that index, pushing the other elements. We have get, where you specify a particular index and you get the object that is there. Remove, which is going to remove the object at that integer index. The other elements will shift over to close up that spot. This is super important. Lots of AP exam questions, multiple choice questions, revolve around the fact that whenever this is dynamic, right? The size of the array list is dynamic. So whenever you delete that thing, it's going to shift over, and you got to be super careful about that. Of note, remove returns the object that it does remove. We have size, which is effectively just length for the array list, effectively. And then we have a toString. We legit have a toString that'll show us the contents of our array list, and that is super nice, so we don't have to code that. Okay, so with that in mind, we're going to pick up there, learning a few more methods out of the ArrayList class, and then we'll actually start doing some ArrayList stuff. We'll look at some common ArrayList algorithms. The first method I want to talk about is remove. So remove is overloaded. That's important to know, but this version, you specify the object that you want to remove. So we just saw a remove that takes in an integer, right, and returns the object that it removes. That integer is the index. Here, with this remove, you're specifying an object. With this version, you specify an object instead of an index. Remove will attempt to remove the first occurrence of the specified object from this array list. It'll return true if we found that object and removed it. Otherwise, you're going to return false. So it's possible, right, that you try to remove an object that isn't even in the array list, at which point you get a false value. But if you do manage to remove one, it's going to remove the object and return true. And just like with the other remove, once you actually kind of remove that element, stuff's going to shift. Let's take a look at some examples. I have an array list of string called smash. And I'm going to take that array list and I add Mario, I add Samus, and I add Link. I'm then going to remove Samus. Well, at this point, my array list is Mario, Samus, Link. So we're going to find a Samus, delete it. Link is going to shift over to close up that gap. We see that here. And we're going to return a true value. So there's a true value sitting here. I'm not printing it or anything, but it's just sitting there. Here's a slightly different example. Right? I have basically the same array list going into the remove. We have Mario, Samus, and Link, but with this one I try to remove Zelda. Notice there's no change to my array list, and we get a false value. Simply put, Zelda's not there. The last one I want to show you is what if there's two occurrences, right? With this one I have Mario, Samus, Mario is my array list. I then try to remove Mario. Well, since there's multiple occurrences, really doesn't matter. We're going to try to remove the first one, and that is the element at index 0. That's going to get removed, deleted, and Samus and Mario both are going to shift over to close up that gap. We return a true value because we did remove something. That's it. That's it for remove. But it's important to know that it's overloaded, right? That you can, you got multiple options there. Set. This is one that we could have used with our before and after tables. It is going to basically remove and insert, effectively combine. The set will remove the object at the specified index and insert the specified object at the specified index. So set is going to take in an integer index. That is the spot that you want to change. And this is what you want to set it to, simply put, right? Here, I got a very similar array list, Mario, Samus, Zelda. And I want to set index 2. Currently, that is Zelda. I want to set it to Sheik. Okay? This is just a simple replace type of thing, but I kind of broke it apart as I'm talking about it in terms of removing and inserting, because realities are that's what the set method does. It calls the remove method it calls the insert method. You don't really see that. That's kind of what we call under the hood. But it's important to note that the removing is happening because take a look. We're returning an object. We're returning the object that was effectively overridden, the object that was removed. So note that set returns the object that was removed. Let's take a look at this example. We have Mario, Samus, Zelda going into it. Again, I'm setting index2 to chic. And effectively, smash.set2, chic, this is Zelda. This is returning Zelda. So I have a string Zelda just sitting here. And again, in this example, I didn't print it, but you could. You could print it off. We could see what did we actually remove. Index of is going to work just like the index of that you know and love from string. Index of will return the index in which the specified object first occurs in this array list, -1, if it does not occur. I have, again, a Mario, Samus, Zelda array list going into this. And I'm saving the value that's returned from smash.indexOf Samus into an integer I, and then we're printing off I. I want to know the index at which Samus occurs in Smash. Well, we can see here that's 0, 1. So this was going to return a 1, which I saved to that variable and then print later. You can, of course, just print this directly if you wanted to, but I'm trying to clearly show this is returning an index. Okay. Also, it just doesn't fit on the slide, right? Between the system.print line and this method call and this comment, I can't put it all on one line. Okay, take a look. In this particular case, I'm looking for chic. I'm searching through Smash using index of, looking for chic. Taking a look at our array list, chic isn't there. And notice, just like with the string version of index of, I'm getting back a -1, indicating that it's not there. I think this may be the last method we're talking about, contains. Contains is less versatile than index of, but basically functions very similarly. Contains will return a true value if this array list contains a specified object, false otherwise. So contains is going to take in the object that you're searching for, and you're going to get back a true or false value, indicating if it's there or not. Okay, very similar. We want to know, does my array list Smash contain Mario? Simply put, yeah. This is returning a true or false value, in this case true. We're saving that into result, and then I print off result to see that. Okay, does it contain false? No. I'm sorry, does it contain false? Does it contain chic? No, that's false. Okay, notice that you could effectively achieve something similar just using index of. Right? There is no real benefit one way or the other, except contains has a cleaner syntax. It's just simply true or false. Is it there or not? Whereas index of, you get a lot more data out of it, right? Because not only, this one's telling me that it's not there at all, this one is telling me it is there and where it's at. And so those are very similar. You don't necessarily have to know contains if you know index of, but it's super easy, so I teach it. So these are the methods I kind of want to add to what we already know. Using those, let's code some common ArrayList algorithms. Write a class ArrayList helper that implements the following static methods. We're going to see a fill. By the way, I can tell all these are static because they're underlined. Notice that the methods that we've been looking at, they're not static, right? They're not underlined here, and these method signatures here, they're not underlined. They aren't static. They're what we call instance methods. They require an array list. In all of these cases, I have an implicit parameter. I have this array list Smash that I'm using, right? As we're going to see with these methods, they are static. The array list that you're actually modifying is coming in as an explicit parameter instead of an implicit one. Okay, we're going to write fill, min, and likewise max is very similar. Matches and remove all. Let's get started. I've got IntelliJ ready to go. I'm going to make a new project by going to File, New Project. Already in my CSA folder, so we are going to call this one ArrayList Helper. Going to expand my project folder, right-click on the SRC, make a new Java class called ArrayList Helper. Okay. This is a utility class, effectively, right? I'm not going to have any instance variables, and because I'm not going to have any instance variables, I'm not going to have a constructor. It's just methods, right? It's just methods to kind of help us out here. Let's take a look at maybe our first one. The ArrayList helper method fill should replace every element in the specified ArrayList with the specified string. Okay. So I'm going to plug in a method header from that, right? Public. It's underlined, so we're going static. Return type here is void. You could return something of note. Just not asking for it here. Fill is the name of the method. And we're going to take in two parameters. An array list of string. That is the array list that I want to modify. Let's give it a name. How about just ARR? Or list. How about list? It's going to be easier to refer to. And then a string that we want to actually replace every element with. All right, this is red, rightfully so. We need to import it. I kind of skimmed over the IntelliSense option, right? As you're typing out, you have the option of importing. We're well past that point. I could delete it and start typing. But if you just simply hover over the red text, you see we have options here. I'm going to do Alt-Enter. And the first option is import class. I think there's actually even a short key to just directly import the class, but there it is. ArrayList is not part of the Java default library. That is java.lang. Right, this is the default library that I'm always talking about. Things like string are in there. Things like math are in there. That's why you don't have to import those things. You already have access to them. Effectively import java.lang.*. Everything that's in the lang folder has been done for you under the hood. Okay, let's give this method some javadoc. We're going to replace every element in the specified array list with the specified string. Replaces every element in list, I'm just referring to it because it is listed here, with str. Okay, now might be a good time to pause if you want to tackle it yourself, but I'm going to walk through it. I'm going to use a for loop. We're going to start at index 0. Array lists, just like with arrays, have index 0 as their initial array list, initial index. And I'm trying to tab over to the condition here. Let's give this a condition. We're going to loop through the entirety of the list. Okay, notice that length is kind of what I'm going for. Length, it's called size, right? So here we have a header for a for loop that'll loop through all of lists from beginning to end. With each iteration, I want the current element in list to become this guy, right? If we're talking about an array, it looks something like this, right? But we're dealing with an array list. This square bracket notation only works on arrays. An array list has methods, right? So think about the methods that we can possibly use. I want to basically replace every element. I want to set every element. So we're going to take our list and we're going to set the current element at index I to str. And that's it. Okay, I'm going to try out this method. I'm going to right click on my SRC, make a new Java class. Let's call that driver. First thing I want to do is plug in a main method and then create some type of array list to practice with. I'm going to let the IntelliSense work its magic this time, right? I'm going to hit enter on this and you see it triggers an import. Let's make an array list of string. I'm going to call it toppings. Let's do something like pizza toppings. That is a new array list of string, and I am calling a constructor, so you see the parentheses here. These little guys, this less than, greater than, in this context we call them angle brackets. This is actually called a type parameter. I don't want you to get that hung up on it. It is something called generics, which again, I don't want you to get hung up on it. Realities are this syntax is not that much different from just making a string array. Right? If I was still just working with arrays, like object arrays, this and this are basically the same thing. You'll notice that I have a length here, and I don't here, and that's because the array list length is dynamic. All right, so let's get some toppings into our array. I'm going to leave this guy out here. We'll do something like toppings.add mushrooms. And toppings.add, how about some cheese? Maybe I should have added that first. And we'll do maybe one more. Pepperoni. Okay. If I just do a quick S out on my toppings, we can see that we have created that array list and we've added these things in order. I'm just using the add, which appends it to the end. Initially, my array list doesn't have anything in it, so mushrooms goes to the end of that, and then cheese goes in after that, and then pepperoni after that. This is super quick and easy to get an array list going that is super dynamic relative to our arrays. Now, what I want to do is call this fill method. Right? It's going to take in an array list. I just made one. And then we want to basically provide it with a string. And in our case, we're going to replace every topping with something else. Right? This method is static. And it's in another class. Okay? So I'm going to call ArrayList helper. That's the class that the fill method is in. Notice I'm not making an ArrayList helper object. This is not an instance method, it is a static method. And IntelliJ is trying to tell us it's static. That's what the italics here means. I'm going to fill. In this case, I want to fill list. What I want to fill it with is, sorry, it's called toppings. I want to fill it with, obviously, the best pineapple. That's going to go through this array list toppings and replace every element with pineapple, in theory. To see that change, I will print off toppings. And we'll tell it to run. Boom. Okay. Now the question you might have right now is, why are we making this static method? You know, why not make a fill method that toppings could just use directly? So you end up with something like toppings.fill pineapple. And the answer to that is this class basically already exists. I can't modify it, right? If I had like direct access to the ArrayList source code to the point that I could like make changes to it, we could in theory add this method to it, but I can't. So instead, I'm making a static method that just takes it as a parameter. Notice that it still causes what we would call side effects, right? The changes that happen here stuck, right? That's very easy to see when I spread it across different classes. Okay. Something of note, in order to make this work, I needed an index. What that means is that a for each loop doesn't really work here. Right? If I try to use a for each loop to go through and basically set these items, it doesn't exactly work because the set method needs this integer index. You could do something maybe like super wonky, but it really just starts to defeat the purpose. Let's take a look at our next method. Hey, that's kind of what it did. The ArrayList helper min should return the string with the shortest length in the specified array list. Interesting. Okay, let's turn that signature into a header. It is public, it is static, it is returning a string. The name of the method is min, and it takes in an array list of string, which I'm just going to simply call list here. We get to reuse that. Okay, this method is going to return the shortest element in list. The shortest, maybe I should say string. Okay, in order to do this, by the way, it's maybe a good spot to pause and then come back. But in order to do this, I need to effectively keep track of what the minimum is, right? We're going to figure out, we're going to have like this placeholder that is my minimum, and I'm going to loop through checking each element to say, is this element shorter than my previous minimum? By the time we get through the entire list, array list, whatever value is in the minimum should be the smallest. So a couple of ways to do this. What's interesting about this is I'm working with strings, but what I'm really looking for is shortest length, which is an integer. So some people, the first thought is just like, okay, we're working with an integer. I need an integer to track my length. But length is something that's stored in the string. So as long as I keep track of the minimum string, I'm in good shape. And I want to do that anyway because I need to return that string. So the variable that is actually going to be your min is a string. Okay, we have written min and max methods before, and I've talked about how you don't want to set it to an empty string, right? Effectively the zero of string. You want to set it to the first element, right? Because if I say that an empty string is my shortest string, well, I'm not going to find anything shorter than that. It has a length of 0. Okay, so what I want to do is save in the first element. How do I do that? Well, I'm going to go into my list, right? If this was, again, arrays, we're talking about list at 0. But again, this square bracket notation, that's for arrays. We're working with ArrayList, which uses methods such as the get method. Maybe as a comment, sorry, not I, but 0. Maybe as a comment, we leave something like list at 0. Those are effectively the same thing. Okay, so I'm going to save in the first element. I'm ready to start looping through my list. I'm going to plug in the syntax for a for loop. And we're going to loop through list.size. With each iteration, I'm going to ask the question, is the current element shorter than my previous min? If the current element, that is list.getI.length. List is an array list. List at I is a string. So I'm asking, is the string's length less than min, which is a string, length? There's a bit there, right? List is an array list of string. This is a single string, and this is the length of that string. I'm asking, is that string's length less than my previous minimum's length? If it is, I have a new minimum. So I'm going to update my min. I will say that min is, right? If I just said I, you notice I get an error message, right? I is an index. I need the element from my list at that index. So list.getI. I'm going to go through the entire thing, and after the loop is over, whatever the smallest element is, the shortest, it'll be stored in min. So that is what I will return. I'm going to flip back to my driver. I'm going to comment out this fill, and I guess this toppings. Maybe I'll put those two together. Right? If it's just nothing but pineapple, it's kind of obvious, right? So what I'm going to have is this test case here, mushrooms, cheese, and pepperoni. It's actually a pretty good test case because notice that my smallest element is not at either end. It's somewhere in the middle. And that makes it a pretty decent test case. So I'm going to print off toppings. Nope, just kidding. ArrayList helper dot min in toppings. Okay, min is the static method I want to call. It is an ArrayList helper, and it needs an array list, so I'll pass it in toppings. That will return a string. What I have highlighted is a string, right? I could, in theory, save it into a variable and then print it off. But if this is all I'm doing with it, we can just, of course, print it right away. So I'm going to do that. And based on this test case, I should get cheese. And there we go. That looks pretty good. I'm not even going to test another one because, again, our test case is so good. The shortest is not at the ends, and that's super important. Okay. A couple of notes about this one. Just like with our other mins and maxes, I actually don't need to start I at index 0. We can start it at index 1. I've effectively already considered the element at index 0 right here. Right? If I set this to 0, this very first iteration is going to compare the minimum element to itself. That's a useless iteration. We can make this a little bit more efficient by starting at index 1. Something else of note, because of this requires that we actually have an element. So some type of precondition I would do here is say something like precondition. I would say something like list.size is greater than 0. Right? If there's no elements in my list, this thing just breaks. The last thing I will say is I don't actually need an index here at all. It is going to be less efficient because of this little micro change, but I can use a for each loop. And I'm going to do that real fast. We're looping through list. Each individual element is a string. So I will say for each string, which I will call str in list. With each iteration, I'm going to ask, is the length of the current element? The current element now has nothing to do with an index. The current element with each iteration is str. I'm asking, is str's length less than minimum's length? If so, I'm going to update my minimum. It's going to become str. Now, I left off braces here. You could have left off braces on the previous one, but look how clean this is. That is kind of the whole point of for each loops. Right? By losing that index, we end up with something a little bit cleaner. Now, this is technically not as efficient. We're going to have that useless first iteration, and I can't control that with the for each loop. But what you get is something that looks clean. Let's take a look at our next method. This one's called count. Count should return the number of times the specified string returns in the specified array list. Sweet. Public. Static. Int. Count. Takes in an array list of string. And I'm going to call that list once again. And that's, oh, we got a string that we're looking for, right? str or maybe target, something like that. Okay, this is going to return the number of times target appears in the list. Note that that could be 0 if it's not there at all. Okay, now is a good time to pause and come back, but we're going to create an integer, which I am calling count. This is different from the method name. This is just a local parameter. I'm sorry, not parameter, local variable. So our initial count is 0, and all I'm going to do is loop through the list, and with each iteration I'm going to ask, are you the string I'm looking for? Are you the string I'm looking for? Are you the string I'm looking for? And every time I find it, we'll increase our count. Okay, so let's get started. I'm actually going to go straight to the for each loop approach here because it is so clean. I will say for each string, which I'm calling str in list. I want to know, is the current element the one I'm looking for? Now, if you'll see, this is yellow, and it says, IntelliJ is trying to warn you that you're using equals, right, which is comparing pointers, because we're talking about objects here. What I really want to use is the equals method. Right, so be careful with that. Now, string is a little special. This works in a lot of cases, and there's some cases where it doesn't work. And I'm not going to dive into which is which. I am going to advise you, when you're comparing objects and you want to know, are they equivalent, use the equals method. Okay, so we're looping through our list. It is an array list of string. meaning each individual element is a string. I'm going to ask with each iteration, is the current element equal to the one that I'm looking for? If it is, right, if this is true, that means they're equal. So I will do a count plus plus. If they're not equal, then count doesn't change. It stays the same. After we have gone through the entire list, I should have a pretty accurate count. So we'll return it. Let's try it out. I'm going to flip over to my driver. Okay, and real fast, we'll do array helper dot count, and what I want to count is in toppings. Let's pick something easy. How about cheese? Okay, simply put, I should get a 1 here. Cheese occurs 1 time. If we bring back our fill, right, I'm going to create the array list. We'll add mushrooms, cheese, and pepperonis. I'm then going to replace all of that with pineapple. Note that this one's going to give me pineapple because that is the shortest element. It's the only element. And so whenever I try to count for cheese, we're going to get 0. And that's correct. But if I replace this with a pineapple, notice that I'm going through basically lots of different test cases. What if there's none? What if there's only 1? What if there's multiples? In the case where there's multiples, we're getting the correct answer. You don't see the most updated one because I had commented it out, but I could easily bring it back in to clearly show that whenever we get to this point, there's nothing but pineapple on our pizza, the way God intended. Okay. Last one we're taking a look at is remove all. The remove all method should remove all occurrences of the specified string from the specified array list. We've looked at 2 different remove methods at this point, but they only remove 1 element. Here, I want to remove all the strings that are equal to this one. Okay. I'm going to start by plugging in a method header. We got public static. This is returning nothing. The name of it is remove all. It takes in a string array list or an array list of string. I will once again call that list, and we'll call our string str or target or something like that. How about we go with target? This method removes all occurrences of target from list. That does mean, oh, how did I butcher that? Oh, it's extra O here. You guys have to forgive me. I was raised in the South where we don't have spelling. It just doesn't exist. That didn't look right to me. Okay, so we're going to loop through this list and try to find these things, get rid of them, that sort of thing. So, let's take a look. I'm going to use a loop. I'm going to loop through our list. And with each iteration, I'm going to ask, is the current element, here I'm using a for loop, that is list.get I, right? List is an array list of strings. This is a whole list of strings. This is a single string. And I want to know, does that single string equal target, the one that I'm looking for? Okay, take a look at this and take a look at this. Right? What we have here on line 45, that's way cleaner than what's going on with line 60. That's the reason you use a for each loop. Okay. The only reason why I'm not using a for each loop is because I ultimately need this index. Because think about what our remove method does. Right? In order to remove, it's overloaded, right? I could provide it an object, but we have a remove where we can remove an index. I want to remove from my list. If this is true, that means I've found the string that I'm looking for, so I want to remove it. I'm going to list.remove I. Okay, after I've gone through the entire string, I should be done. I really don't need to do anything else. Let's take a look at this. Okay, this one is returning void, right? So it's nothing to print here. Instead, we're just going to simply call it, similar to what we did with fill. I'm going to remove from toppings pineapple. I should put it in quotes, pineapple. And in order to see that change, we can print off our toppings again. Okay, keep in mind at this point, it should be nothing but pineapple. So all three should go, and we should be left with nothing, right? So let's try that out. What? Okay, let's think about what's going on here. Your boy did this on purpose. Misspelling occurrences, not done on purpose. Doing this, that was on purpose. Okay, I've talked about this slightly in the last video. The dynamic sizing of ArrayList is something that students get excited about. They're like, this is way easier. But it creates new problems, right? Keep in mind that whenever you remove something, it's going to shift elements over. Let's kind of trace this, right? I'm going to use our pineapple as an example, and I can just copy and paste this bad boy. So list coming into this looks like that. Pineapple, pineapple, pineapple. Right? I is going to start at index 0. So I is here. We're going to look for target. So let's just say that our target is also pineapple. We're ready to start looping. We're going to ask, is I less than the size of our list? The size of our list is 3. So that's true. I'll enter the body. We're going to get the element here. That's pineapple. I'm going to ask, is that equal to pineapple? That's true. So we enter the body. We're going to remove from list I. That's this guy. Right? We're going to delete that. Those elements are going to shift over to close up that gap. That's the end of the iteration. We do an I++. I is now here. We're going to ask, is 1, that's the current index, less than our size? It is. We'll enter the body. We're going to ask, is this equal to pineapple? It is. So we're going to remove that one. That's the end of the iteration. We do an I++. I is technically 2 at this point. We'll ask, is it less than our size? Not a chance. Okay, so you see what happened there, right? This dynamic shifting of elements actually causes a problem. Now, a couple of ways, several ways to do this. One that's a little janky is that whenever you do this, right, if this is true and you remove the element, you do an I minus minus. What that means is that these two kind of offset, and so it solves the problem, right? If I were to do this, you would see that we end up with nothing. We are successfully removing everything. I don't like this, right? Because one of the advantages of a for loop over the while loop is everything related to the counter variable shows up here. That is kind of the design of it. So when you have a change to the counter variable somewhere down here, that's awkward and janky. What I think is big brain, the big brain approach is go backwards. Say what? Let's loop through it backwards and do it. Right? I'm going to start at list.size. What is the last index? List.size will be out of bounds. The last index is list.size minus 1. We're going to then go the other way. So as long as I is less than or equal to the first index, we're doing an I minus minus. So I'm going to loop backwards. That's the only change I'm making. We're still doing the same equals. We're still doing the same removal. And if I run this again, you'll see that our list is empty. Why don't we trace this? Exact same example. Except this time, whenever we get here, I is going to be list.size minus 1. I is here. I'm going to ask, is I greater than or equal to 0? It is. We're going to ask, is the current element equal to the one that we're looking for? It is. Okay, let's remove this element, right? In theory, all this stuff shifts over and closes up that gap, but it's not a problem. That is the end of the iteration. We're going to do an I minus minus, so I gets smaller. It's now here. We're going to ask, is I greater than or equal to 0? It is. Is the current element equal to the one that we're looking for? It is. We'll remove it. That's the end of the iteration. We do an I minus minus. I is now here. We'll ask, is it greater than or equal to 0? It is. Are the elements equal? They are. We're going to remove this element. We do an I minus minus. I is now -1. We'll ask, is it greater than or equal to 0? It is not. And that is the point at which we stop. So I think this is a pretty big brain approach, and one that I tend to recommend, right? If you're removing elements, consider looping backwards, because then you don't have to worry about that dynamic shifting problem, okay? The last one I want to show you is the biggest of brains, and I'm not necessarily saying you need to be on this level, but the remove method is overloaded, right? Let's go back to our slides. I don't even know if it's on this one. Yeah, it is. Let's go back to our slides. Take a look at this. Remove will return true if the specified object was successfully removed from this array list, false otherwise. So this version of remove, I tell the thing I want to remove, and super important, I get back a true or false value if it's successful. You ready for this? While list.remove target. Okay, this is going to go into our list, try to remove the target, right? Then if it removes something, I get a true value, and it's going to try to do it again. Now, I'm using it as the condition, right? Like you could basically expand this to, while list.contains target, you basically are doing a list.remove target. But because this returns a true or false value, I could just shortcut this and use it as the condition. Okay, then it's just like, okay, what's the body? You could effectively do nothing because this is performing your action and returning your value. You could also just put a semicolon here, which is basically no body. And I'm going to run this again to show you that it works, and you'll see that we have an empty array list. I'm not expecting this from you, but this is like the biggest of brain. Big ol' wrinkly brain. Guys, I think that's going to be it for our slides, and I do actually end up showing this big brain strategy. Hope you had fun. I will see you in the next one.